Bismillahirrahmanirrahim. Assalamu alaikum. Okay, in the previous session we talked about the key value database, and we said that the key value database is the simplest NoSQL database that we have. And we said that key value is a data structure which is more complex than the array. In the array, we have some data which the indexes are integers and the values are the same type. But and then we have something else called the associative array, and in this associative array the index, it could be anything and not just numbers, and the values could have any type and they don't have to have the same type. The key value was an associative array. Okay, it's something similar to the associative array, and in the key value we have a key. The key is like an address of the data, and it could have different types. It could be a string, list, okay, and the values are the data that we are storing in the database. uh, each each of these data has a key which refers to it. In the key value database, we have a namespace. This is the only structure that we have in the key value database, and we could put our data into different namespaces. And the only limitation that we have in the namespace is that the keys should not be duplicate. Okay, we shouldn't have duplicate keys in each namespace. Okay, and then we said, how could we construct keys? Okay, we talked about this issue. How could we construct keys? And we said that we could use this method for constructing keys: the entity name, the entity identifier, and the entity attribute. Okay, for example, for the customer first name, we will have this key. And then we said that in the key value database, the keys are related to the values with hash functions. Keys are related to values with hash functions. And the hash function generates a number. Okay, we said that the hash function is a function that gets the key and generates a number in a base 16 number, hexadecimal number, and that number is the address of the data on the memory, on the hard disk. Okay, so this is how keys and values are related to each other using the hash function. And we said there is a challenge in the hash function, which is collision. We talked about it. And then we said, how could we convert a relational database to a key value database? Okay, in the in the relational database, we have some tables. Okay, we have some tables, and if we want to convert them to the key value database, uh, we could use this method, and for in this method the keys are built like this. Okay, in each table, the name of the table, for example, here it's the customer table. Okay, the name of the table is customer, the ID of the customer is this, and this is the attribute. Okay, so for each table we should have the name of the table and the ID of each row, and then the attributes. Okay, so we could build these keys for for each row. Okay, all of these keys are for one customer for one row of the customer table. Okay, so we have it like this. So we could convert all of the tables into key values, and this is what we can do. Okay, and then we said the main features of the key value database. One of them is simplicity. Okay, simplicity is that this database is very simple. It doesn't have any limitation. And for example, we don't have a schema. Schema is the definition of the database. What are the data? What are the attributes? What are the type of the attribute? The name of. Okay, so we don't have a schema. We don't have a definition of the data we want to use a database for. And then the data types are free. The attributes could have any types of data for their values. And this was an example of the customer address, that it could have different types: a string, a list, or a JSON object. The second point was about the speed. We said that in the key value database we use RAM to accelerate the database. When the operations are done in the database, they are stored in the RAM memory, and then we do it on the hard disk later. So the speed of the application or the software which is using this key value database would be higher, because the data is stored in the RAM memory. And okay, this was a challenge about this RAM. When the data, when the RAM memory is full, we have to delete some of the data in the RAM memory, and we could do this using different strategies. Okay, we could delete some data from the RAM memory. Okay, and then we talked in the previous video. In the previous video, I put on the DARSA site, I talked about scalability. I talked about and before that, I talked about the cluster, which is a group of servers. Okay, we talked about this concepts in the online session. The cluster, the ring, it was a specific cluster, a structure and design, which the servers are connected together like a ring. And the partition was a group of servers in the cluster which do a specific task or job. And each partition it has a key, partition key, which is used to access the servers in that partition. Okay, this was the subject I talked in the last video I put in the DARSA site. I talked about replication. Okay, replication was is a concept which we have in the key value database, and I talked about it in the SQL database too. And the replication is that we have some copies of our data. And why do we do this? Because we want to have high availability. High availability means that when a system and a server fails, the system could still continue its processes and the work it's doing. So we have replication. For the replication, we could have different strategies in the key value database. One of them is master slave replication. Okay, master slave replication. Okay, in the master slave replication, we have a server which is called the master, and the other servers are slaves. The master server is responsible for read and write operations in the database, and the slave servers, they are only responsible for read operations. So in applications, in most of the applications, the number of read operations is much more than the write operations. So we have some multiple slaves and we have one master in this strategy, and we could add more slaves if the number of read operations is going higher. Okay, we talked about this, and this is the structure that we have here. We have a master and we have some slaves here. Okay, but as we said, the problem of the master slave replication is that the master server may fail. If the master server fails, the slaves in the will send some messages to each other, and they will select a new server as the master, and after that the master server will continue its work. The new master will continue. Okay, so this is a problem in the master slave replication, which has a solution. Okay, so I talked about these issues in the previous sessions and the videos. Okay, now in here I want to talk about this masterless replication. This is the next this is another type of replication that we have in the key value database. Okay, so in this type of replication, uh, all the servers, they can have read and write operations. Okay, in the previous structure, only the master server could do write operations, but in this structure, the masterless replication, that we don't have a master, all of the servers, they could do read and write operations. Okay, uh, and when we have this, okay, all the servers could do read and write operation. There is a problem. A problem occurs here, is that there may be some situations which two servers, two different clients. Okay, this is one client. This is another client. Okay, client means a user that is connected to our system, to our website. Okay, this user wants to do something. For example, here it wants to buy a ticket for the cinema, for example. Okay, we have an application for getting tickets for the cinema, and there are two users, they want to get a ticket for the cinema. Okay, and the server, the database, gives them the same ticket. Okay, you see it, this ticket and this ticket are the same, because all of the servers, they could do read and write operations. Okay, so a single ticket is given to two customers, and this is a problem, so it should be resolved in the application. We should check that um, is the data that is um, created, is it duplicate or not? It should be checked. Okay, this is a problem that could occur in this type of replication, the masterless replication. Okay, so the solution of this problem, it could be in the application or maybe in the database, maybe. Okay, you could have different solutions for this problem. And in the masterless replication, uh, if we have four replicas, what does four replicas mean? It means that for each database uh, we have four copies. We have four copies. Okay, this is what four replica means. Okay, for example, this is server number 8. Server number 8, it has a replica on server number 1, on server number 7, on server number 2. Yes, that's all. Okay, so we have four copies. Okay, the first copy is on this server 8. The second one is server 1. The third one is server 7, and the fourth one is server 2. So we have four copies of the data. Okay. One other point about the key value database is how do we store the data in the cluster? Okay. As I, as I said, each of the key values, we give the key to the hash function, and the hash function generates an address. Okay, we could divide the hash value to the number of servers and then get the remainder of that. Okay, and use that for saying which the data should be stored on which server in the cluster. Okay, when we divide it by the number of servers, the result would be a number that specifies the server which we should store the data on it. Okay, one other issue about the key value is the compression. Okay, the key value databases are memory intensive. It means they use a lot of memory on the hard disk. So we have to have a compression strategy to avoid these large files. Okay, there are different compression algorithms which there are a trade-off between the speed of compression and the size. Okay, so compression is a very important task in the key value database because the size of the database is very big. Okay. And the last points about the key value database is that we have some limitations to search for values in this database. Doing all the operations that are done in the key value database, they are written by the developer. Okay, the developer is the person who's creating software. Okay, he has to write the operations that he needs on the key value database himself. Okay, so uh, this is what the developer has to do. Okay, in if you remember, in the SQL database we had a language for doing operations on the data, which was SQL. But in the key value database we don't have such a language, and the uh, the developer should write the operations and function he needs to do the operations on the database. Okay, thank you very much. Okay.